Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 13, Section 6, Graphing Quadratic and Cubic Functions. One thing I want to get out of the way before I talk about graphing these functions, because graphing them is quite simple, is I want to talk about what it means when someone says to you, write, like for example, if I said, write a formula to represent the volume of a cube, so we're talking about volume of a cube, as a function of edge length. Okay, so when it's asking you to write a formula as a function of something, okay, so we're writing the volume formula for a cube. So we're going to start with that. The volume formula for a cube is any singular edge to the third power. Okay, so volume of a cube is the edge to the third power, because volume of a cube is length times width times height, and cubes have congruent sides. So you're taking a number like 5 and doing 5 times 5 times 5. That's the volume of a cube. Now what they said was write a formula to represent the volume of a cube. Here's the volume of a cube. They want you to write this as a function of edge length. And so what they mean by that, it's the same exact thing, except instead of writing volume, you're looking to write volume as a function of edge length. And all this is saying when I plug in a number for E, what function does that serve? When I plug in a number for E over here, what function does that serve? Technically, the function of E is volume. So when I plug in 3 for E, what's the function of E? What's it getting me? It's getting me the volume. And what is that volume? So basically, it's just another way of writing your volume. It's another way of writing y in y equals mx plus b. So in linear equations, you have y equals mx plus b. So if you wanted to write a linear equation as in this form, you'd be writing it as a function of x, because typically in a linear equation, we're given m and we're given b. And so the variable we're solving for is, or the variable that you use to solve for y is x. So this would be a function of x. So basically, when I plug x into this equation, when I plug in a number for x into this equation, what do I get? That's what that's asking you, or that's what they're telling you when they talk like that. It's basically just another way of writing y. It's another way of writing volume. Okay, it's nothing that should be super confusing, but it does take a little time when you're reading it to kind of wrap your mind around what is it they're asking me. But now to get to the graphing. The graphing is super simple. Quadratic equations and quadratic and cubic functions are pretty simple to graph. Okay, like we've discussed in previous videos, quadratic functions typically they will have a variable to the second power. So an example of a quadratic function would be y equals x squared plus 3. So there's a quadratic function. If I wanted to graph it, it would be pretty simple. I need to decide what x is going to be. Remember, x, just like with linear equations, can be anything. I can plug in any number I want for x. Okay? Over here, I'm going to write x squared plus 3. And that's going to be, the reason why I write this is because when I solve this, that gets me my y value. So this is also known as your y value. Because if x is 1, for example, then y is 1 squared plus 3, which is 4. So my ordered pair is 1, 4. Now I have 1 point on my quadratic function. If I chose 0, 0 to the second power is 0 plus 3. There's my second point, etc., etc. A cubic function is pretty much the same exact thing, except now we're working with a function that has an x to the third power. So instead of seeing y equals x squared, you may see y equals x cubed. And we'll go with minus 1 this time, just to change it up a little bit. Okay, so you may see something to the third power. So again, here's your x coordinate, here's your y coordinate, and at the end you'll get your ordered pair. Plug in a number for x. We plug in 1. 1 times 1 times 1 is 1, minus 1 is 0, ordered pair of 1, 0. Plug in 0 for x. You get negative 1, 0, negative 1, etc., etc. It's the same concept as quadratic functions, just cubic functions have different exponents. So you plug in a number for x, solve for y, you then have your x and y coordinates, which now represent your ordered pair, plot your ordered pairs, and you've just graphed your function. Now, the difference between quadratic and cubic functions compared to linear functions is you can't get away with just graphing 2 points like you can on a linear function. 2 points make a line. 2 points do not make a curve or wave. So if you're graphing a quadratic or cubic function, I suggest you graph at least 5 points. That is the minimum I require, is 5 points, so that you can get a pretty good description of, so you can get a pretty good visual of the function itself. Now, what numbers should you be plugging in for x? For those 5 numbers, pretty typical, because you don't want to get numbers up in the hundreds and thousands if you can avoid it. So you typically want to stick with numbers like negative 1.5, negative 1, 0, 1, and 1.5. Those are my 5 numbers of choice to use for x. Obviously, you can use anything you want. Not going to prevent you from doing that. But if you use the same 5 numbers, it makes life easier. You can use a calculator in this section to do the calculations out if you feel like you need to. I'm okay with that. I'm more worried about whether or not you can graph these correctly than anything else. So if you have any questions, pause the video, let me know. Make sure you took good notes, and you are officially at the end of the book. There will be no more videos on pre-algebra stuff. In the future, when I get time, there will be videos on algebra, which you will see in 8th grade. So stay tuned for those. I don't know if I'll have them sooner or later. So